Hi everyone, thank you so much for joining and thank you for liking this video. Thank you for sharing this video and thank you for subscribing to my YouTube channel. My name is Percival Pagati. For this video, I'll be showing you a real life example that can be solved using high school trigonometry. And one of the reasons why I'm doing these videos in my channel is because most of the people have a notion that high school math is useless, but I want to show you more and more of these examples on how you can use high school math to solve critical real life problems, and even how you can essentially make money just using high school math, and how you could save money for businesses just using high school math, and how you yourself can essentially apply high school math in your own personal life, right? In this example, I'll be precisely showing you how you could use a high school trigonometry to solve a problem, right? So what I'm going to be doing in this video here is I'm going to give you an example, a problem. I'll state the definition of the problem. Probably can even read it here on the screen. And after stating the definition of the problem, then I'll remind you of the high school theory or high school notes of trigonometry, and then we can then use those theories or theorems, high school theorems or principles, to solve this particular problem, right? So let's state the problem. Now suppose you are an architect, right? And you are designing a roof for a house. You're an architect and you're designing a roof for a house, and the roof needs to have a slope of 30 degrees to ensure proper drainage during rain. The height of the roof at the highest point is 5 meters. This is a definition. How will you solve this problem? So what I want you to do is pause this video, and I want you to think of trigonometry and how would you solve this problem. All right, so now I'm going to show you how one will solve this problem. I'll give you a lot of examples or a lot of ways on how you would solve this problem. But firstly, let's understand the problem together. I'm going to start drawing pictures of the problem, and it's one of the things on how you solve a mathematical problem, a scientific problem. You are in architecture, so you need to be able to draw down the picture here, right? So let's play the role for an architecture. So in this case, you are designing a roof, right? So let's say you have a roundabout, get a different color, designing a roundabout. And the reason why I'm making an example of a roundabout is because I'm a South African, and one of the Nguni architecture is the housing architecture is something called roundabout. Make your own research, and it's such a beautiful design. It looks like this. Make your own research about that, and such a beautiful design. So let's say you are an architect, and then you are designing a roundabout, and what you want from this roundabout or from this design is you want to make sure that the roof the roof the roof is, it give you that the 30 degrees angle to make sure that if it's rain, right, there is that drainage during rain, right? Don't want the rain to stay on your roof, so you want to make sure that this is in the 30 degrees angle. And what you also want to do is you want to make sure that your height of the roof is 5 meters. Let's call it 5 meters. Want to make sure that the height of the roof is 5 meters. So the reason why I'm putting 90 degrees there is because you want to make sure that this rooftop is perpendicular to this height, right? You need to make sure it's perpendicular. If not perpendicular, so your roof is going to slide a little bit. So this should be 90 degrees. So this is what you're given. Now let's use high school trigonometry to solve this problem. So what you want to know is essentially you want to design a roof and give the right sizes, because you're an architect, so you need to design the right sizes. What is the size? And let me maybe give it points. So let's say this is A, this is B, this point, this C, this is D. So what you want to give different points, A, B, C, D. So you essentially you want to know what is the size, or rather the measurement of this and the measurement of this, right? But if you look at this carefully, just carefully, if you take a line that is perpendicular to this line, right? So essentially what you want to do is you want to take it and put it at the center of this line, at the midpoint of this line, meaning therefore this line AB is equal to this line BC, right? So we're just dividing at the center. And essentially because you are designing a roof, therefore this side of the roof should be equal to that side of the roof. That's basic design, right? So this is the information that you know. And how do we do this? We just read a statement. Suppose you're an architect and you need to design a roof for your house. The roof needs to have slope of 30 degrees to ensure the proper drainage during a rain. The height of the roof at the highest point is 5 meters, right? And the problem is design the roof of the house. That's the problem. You want to design the roof of this house. Okay, in this case, a roundabout. So yeah, this is the information that you have. Now, how do we use high school math to solve this problem? Great. So there's something called old hands kettle and hallowed till old age. So this is one of the way of somehow way of reminding myself of these letters here. Let's call it capital A. One will say so Sokatoa, which essentially means sine, in this case 30 degrees. Sine of 30 degrees is equal to opposite side of 30 degrees divided by the hypotenuse side of 30 degrees, and cos 30 degrees is equal to adjacent side of 30 degrees over the hypotenuse side of 30 degrees, and tan of 30 degrees will be equal to opposite side of 30 degrees over adjacent side of 30 degrees. Right. So what we want to solve here is we essentially want to know what is the size of AB and what is the size of AD. And if you know the size of AD, of course you know the size of DC. If you know the size of AB, you know the size of BC. That's basically what we want to solve here. So let's go ahead and solve this problem. So you have size of AB. Size of AB. Let's try to figure out the size of AB. So you need to choose whether you want to use sine or cos or tan. Essentially, AB is the adjacent side of 30 degrees. So we can use cosine if you want to. We can use tan if you want to, because we are solving for an adjacent side of 30 degrees. Let's just use cosine. If you want to, you can use tan as well. We should get the same answer, right? So if you use cosine, so you have cos 30 degrees is equal to the adjacent side. What is the adjacent side? Is AB. So let's just write that down. AB. And what is the hypotenuse side? AD. There we go. So we cannot use cosine. The reason why is because because we don't know AD, we don't know the adjacent side, but we know the opposite side. So this is how you do it. right? And that's the reason why I didn't want to just immediately jump to tan. I wanted to do cos so that you can see why you wouldn't be able to do cos. And I don't want you to freak out. It's just you have to understand, oh, we don't have the hypotenuse side. We don't have the adjacent side. So you don't have to use cosine, but then you can use tan because we have the opposite side. And the opposite side is 5. And we are looking for the adjacent side, right? So let's use tan to solve this. So you have tan of 30 degrees equal to the opposite side again is AB. No, sorry, BD. That's the opposite side. The opposite side of 30 is BD. That's the opposite side. BD over the adjacent side of 30. This is the adjacent side of 30 is AB. So there's AB. So this is gonna be BD is 5 meters. And AB is AB. That's what we are trying to solve. And then from here, you can now use your algebra. So you have tan 30 degrees is equal to 5 over AB. And then what you can do is you can cross multiply. So you're going to have AB is equal to 5 over tan 30 degrees, right? Because you're solving for AB. And then from here, you can take your calculator and then just punch in your calculator 5 over tan 30 degrees. And you should get 5 root 3. That's 5 root 3, which is approximately 8.66 meters. That's basically your AB. And that is your AB, right? So if that's your AB, therefore, remember what you're looking for. You're looking for this side of the angle. So this is AB. AB is 5 root 3. So, and BC is 5 root 3 as well. So what you have found out is this is 5 root 3 and this is 5 root 3 meters. So therefore the distance or the size of AC, right? The distance between A and C is 5 root 3 times 2, right? 5 root 3 plus 5 root 3, or 5 root 3 times 2, which is 10 root 3. So AC is 10 root 3. Okay, so that's your size of that's basically your length, should be 10 root 3. And then from here, now we need to find this slope. We need to find the slope here. What is this slope? Which is AB. And of course, you find AB, you know DC, sorry. If you find AD, you know DC. Okay, so how do you find DC or AB? Again, we look, this is what you call a hypotenuse side. Okay, cool. Which one should we use? We can use this one because it has hypotenuse sides. You can use this one because it has hypotenuse sides. You can pick anyone, right? Why? Because we have the opposite side. Opposite side is 5 meters, and we have the adjacent side. We just calculated it now, which is 5 root 3, right? We have the adjacent side, 5 root 3. So you can use that, or even you can use Pythagoras, right? Because now this is a right angle triangle, right? So you can use 3 things here. You can use Pythagoras, you can use sine, or you can use cos. All of these 3, they should give you the same answer. So I will encourage you to go ahead and use these trees and try to figure out yourself if you can actually get the same answer, okay? So what I'm going to do is I'm going to just pick sine because this is the first one I see. Right, that they should give you the same answer. Pythagoras, cosine, and sine. And please comment. Make sure you comment if you have used tan. Make sure tell me, say, hey Percy, I've used cos and it works. If you use trigonometry, Pythagoras, tell me, hey Percy, I've used Pythagoras, it works, right? I'll be excited to see those comments. So you're doing the same thing here. So you have, I'm saying I'm going to use sine. So sine is, let me take a black page. Sine 30 degrees is equal to opposite. Opposite is 5. The opposite side of 30 degrees is 5 meters. So 5. And the adjacent over hypotenuse. So this is a hypotenuse. That's what you're looking for, which is AD. And then you cross multiply again. So AD is equal to 5 over sine 30 degrees. So 5 over sine 30 degrees is equal to 10 meters. So let me know if you get 10 meters for AD. So if AD is 10 meters, therefore DC is 10 meters. This is how an architect would essentially use high school trigonometry to solve a very important uh, problem in housing, in designing a house. Very important. The angle of the house is it's in the right. Everything is in the right corner. Every angle, every size of everything when you're designing a house. Most of the architectures they are using trigonometry into its fullest. And what you just learned right now, it's a high school basic maths that would able to solve a very important problem. And without understanding this basic maths, you wouldn't actually able to design a good looking house. Thank you so much again. Make sure you share, make sure you comment, make sure you like if you like this content. And let me know if you do like this content, if you want me to continue making more examples of high school maths, please let me know. Real life example of high school maths. Please let me know, and I'll make sure I'll write them down. I'll try to figure out other ways to solve these problems, or look at different disciplines and how people using maths. Maybe go to medicines. Sometimes when architect today, maybe go to engineering, you go to data science. We'll play around with all these nice field of science and how they're using maths, and how we can actually somehow see a light in high school maths, and how is that important. My name is Percival Parati. Thank you for joining. Don't forget to hit the subscription button and the notification bell so that you'll be the first person to know when I post a next video. Boom. This year I'm only taking 10 students. Please call me. Talk to your parent first and call me. I'll let your parent call me if you want to be part of this group. I'm only taking 10 students. I'll be helping the students with the homework, with assignments, and the JOMA group. Just only 10 students for this year, and I'll focus and dedicate my time to help these students excel in mathematics. So if you want to be part of this group, please don't miss out. Join this group, talk to your parents, let me know about, and let me know if you want to be part of this group. Join as soon as possible. The seats are limited. You don't want to miss this out.
For eggs, and then I get X1 and X2, and then I still remember this. Okay.